Hi everyone, Tony and Purchase coming to you, otherwise known as Tony I, the Organ Guy. And today this is Organ Technology Part 20, and we're going to talk about getting an oboe voice onto my 50-year-old Rodgers 33E. Now last time we talked a little bit about filter circuits, and we talked about rerouting the Vox Humana and the percussion circuits and all of that, and how I had a little trouble with the preamp and solved that problem. And we talked a little bit, I was showing you a filter off of a Schober organ, which was a kit instrument, and it was kind of a nice illustration to see a simple filter circuit and talk a little bit about how that filter circuit manages to reshape the harmonic structure coming off the tone generator so that we get the different voices, what makes it an oboe, what makes it a flute, and so forth. And I mentioned that just for fun I was going to plug that filter circuit into the 33E and just see what happens. Well, nothing happened. And I think the problem is that the orientation, the polarity orientation of that filter circuit was not the right direction. So first, let's take a brief look at what in the world that means and why it would affect the design of the filter circuit. Now honestly, I didn't expect I was going to get a great oboe sound by plugging a Schober filter into a Rodgers organ. I just wanted to see what would happen just for fun and leave it at that. So first, let's take a quick look at electrical polarity and how that affects tone generator circuits in analog synthesis circuitry. So if we take a quick look at how electrical current comes into our home, you have a transformer, you've got high voltage over on this end, and then you have your house current on this end, which is a center tap system. So we've got hot 1, neutral, and our hot lead number 2. The neutral is, of course, connected to ground, both at the transformer and at your home. The differential of potential between the hot and the neutral is 110 on each half. And if you go hot to hot, you then have, let's do it this way, 220. This is called a single split phase system. Now, in a similar way, the DC current that comes into our power supply from our power supply on the 33E and a lot of other analog organs is kind of a similar setup. We have a center point that is our ground. We have our volts positive and our volts negative. Now, the oscillators that are used in the 33E like to see both voltages so that they can generate a full wave oscillation. The full wave oscillation is used on our tibia. There's a variation done for the main. And what happens is, let's say this is our neutral point. The main oscillators are generating a square wave that goes both positive and negative. So forth. Positive, negative. But in the circuitry, a diode cuts off the positive side, leaving the negative square wave to pass through to the keying circuits, which are keyed from a 12 volts negative source. And this is why the orientation of the filter circuit, whether it's positive or negative, matters. Now this is true of the organs that Rodgers built in the early days. We're talking 1960s. In the 70s, they switched over to 12 volts positive for the keying, so they'd have to do the opposite here. Make this the negative side and this the positive side, and then you could use a positive voltage keying to trigger and let the tone on through to the filter circuits. So if we look at our filter circuits, we see that they have to be oriented for a negative output coming in at this point. So in trying to find an oboe filter that would work on the Rodgers 33E, none of the early theater organs had an oboe on them. I could not find any schematics that showed that, but some of the classic organs utilizing the same tone generator system did have oboe. And so here I'm showing the relevant part of the oboe circuit that I found on an early Rodgers classic organ. And here is the Kinura circuit from the 33E. And you'll notice there's some striking similarities. 0.47 microfarad capacitor, 0.47 microfarad capacitor, 1K resistor, 1K resistor heading on out. Here's our input side, here's our output side. You'll notice that the same branch to ground running both through induction coils and capacitors are present on both filter circuits. However, the values are different. And on the oboe circuit, we have this additional induction coil and branch circuit going to ground with a capacitor in place. So what I've decided to do is I don't find the Kinura all that useful. So I'm going to try and convert this Kinura circuit into this oboe circuit. So how are we going to do that? Well, the oboe needs both of these coils to be 900. It needs these capacitors to be a slightly different value, and it needs this additional circuit here. So we can change this to 900, change these to the appropriate values, 1.5, and then I can build this circuit here on a separate board with our 400 turn coil and our 0.002 capacitor running to ground, and I can create an insert point right here, and that's done. In the physical world, I'll just disconnect this capacitor, but in the schematic world, it'll look like this, and we'll call this point A and this point B, point A, point B. So I can put these two components wired up on a separate board, mount that near where this is, create this insert point, run the wires from A to A, B to B, change these values, and we should be home free. So looking at this, I have a 900 turn coil and I have a 400 turn coil. I need a 400 turn coil and two 900 turn coils. So I got to come up with one 900 turn coil to make this work. So let's take a look at this. This is a surplus circuit board I have from a Rodgers organ built in the 1980s. The filter circuitry for these later organs is almost identical to the circuitry we see for the earlier instruments. The difference is that we have a more sophisticated keying system. We have separate keyers on each voice in the later models. So this keyer here is for the swell division. This keyer is for the pedal. And we actually have four filters. We have the 8-foot trumpet and the 8-foot oboe for the swell. We have the diapason, and we have the 16-foot fagot for the pedal. So what I'm going to do, now let me back up just a skosh. I had thought that, well, maybe I can just route the 33E's output into these filter circuits and get these voices. Well, no. Remember I talked about at the beginning of this video the polarity orientation. These circuits are oriented for positive keyed, and the original is oriented for negative keyed, and it does make a significant difference. However, the individual coils themselves, they don't care. They're not polarity sensitive. So these are 900 turn coils, and this is a 400 turn coil. So I'm going to rob one of these coils off of this circuit board to give me my extra 900 turn coil that I need down here to convert this Kinura into an oboe. So in the next installment, number 21, I'm going to do a video where I just show the work, right? I'm going to build the little sub-circuit that's going to be dubbed in. I'm going to change the component values directly on the Kinura circuit inside the 33E, as well as do some other maintenance and repair work on the 33E, and you'll get to see exactly how this all goes together. And you'll get to see me turn everything back on and see if it works or not. So that's it for today. Thanks for joining me. Hope you enjoyed this little explanation of what's going to happen next on the 33E. In some upcoming episodes for organ technology and other things that I've got going, we've got some interesting stuff that you guys might want to take a look at. I'm building a rig for my live performance of my original ambient experimental music, and those videos are called Tony Imperatrice Live, Rogue Festival, and Beyond. You might want to check those out because that's a whole different side of the whole organ technology game. I'm also going to be doing some videos with this other instrument that's in my studio. That's a Hopwerk organ, and we're going to talk about how Hopwerk works and how you can use Hopwerk just on your computer with some MIDI keyboards or use it on a ready-built Hopwerk console. Also another part of the whole world of organ technology. So join me for all of that, and we'll see you next time.